I want to talk about how to use AirMagnet survey. The first thing you want to do is to open up a new project, and you have a choice here between the GPS and the non-GPS projects. And then the first thing you need to do is import a floor plan. So this can be an image, basically. Any image file is acceptable. And then you want to choose whether or not basically the type of space you have: office, open office, warehouse, and outdoor space, and that determines the radio frequency obstruction level, and the signal propagation assessment is automatically inputted, but you can change the signal propagation to anything you want. And when you press next, you can enter a description of your survey, and that will generate a new project. In this case, my map has markings where I'm going to put access points. This is an outdoor survey, and I'm choosing the passive survey. Passive means that we are looking for radio frequency interference before we've connected to an access point. So what are the existing interferences? And we just take our guy and we walk around the map, and every time we move, we click, and that registers our data. So you would put this on a laptop. Microsoft Surface tablets are very good for making these surveys, and you just want to walk around, and every few feet just click. You can pause the survey and then click again to resume. If you make a mistake like I'm making, then you can press the undo button. Now note I used an image from Google Maps to do the survey because this is an outdoor survey. We want coverage in the yard. When you save your survey, your passive survey data, then you can display it. I should mention you should wait a few seconds after each step to collect the data. What I'm going to show you here is the actual data we collected. You can see we can filter the data by SSID, and we can filter by channel on the left. If we drag this bar, we can set a minimum or maximum threshold for the signal. In this case, our signal ranges between -60 and -80 throughout the outside. The building itself has Wi-Fi. On this screen, we've done a passive survey for a indoor building, which also has a good Wi-Fi coverage in the office, and which is green at the bottom. And as we drag the slider up, you can see we have poor coverage up at the top. We have very little Wi-Fi coverage in the warehouse. So if we set our signal to 70, you can see in the gray areas we have no coverage at all, pretty much. Of course, we can zoom in to any area on the map. And the measure mode helps you calibrate the dimensions of the area, which will affect the results of the survey. So you're asked to input the measurements ahead of time, but if you didn't, you can always measure later. And the laser measure is good for this. So measure 2 points on the map, and then select them with the push pin. And in this case, we measured 94 feet. and then we enter the actual dimension. 94 feet is what the software thinks it is, and let's say it was 150 feet, so we put 150. It automatically recalibrates in the X and Y direction. So this software also lets you plan the location of some access points for a so you can choose where your access points are going to go, and you can enter different wall types. So you can draw a brick wall or a drywall, and that lets the software understand signal propagation. It can predict how far the signal will travel given the wall. You can also highlight areas based on the type of area that you have. So a cubicle, an office space, a warehouse. So in this case, I'm highlighting cubicles, and the software understands that they are going to block the signal a bit. And this, I'm highlighting a warehouse. You can't overlap regions. The software will get confused. But so if we highlight this area and say it's our warehouse, and then we highlight the next area and say it's an elevator shaft. Well, I made a mistake here. I'll do it again. And you don't have to draw a square. You can draw any shape you want, basically. So that's our elevator shaft, and this is our warehouse. And then what we're going to do, we're going to add, we can add areas where we want coverage, or the software will assume. So we've highlighted this area. This is the area where we want Wi-Fi coverage, and then we can add exclusion areas. So these are areas where we're not allowed to install access points, let's say. And then the advisor, we set our parameters. So what is our minimum signal strength? What kind of APs are we using? Their height, the antenna gain. In this case, we're doing 2.4 and 5 gigahertz, and we want to have a minimum of minus 75. Your parameters might be different, and then we can choose which channels we plan to broadcast on. And high density applications, you need more channels, and then the software will automatically figure out which areas get which access points based on the coverage, and it does some number crunching. This takes a few minutes, could take a while depending on the size of your building. And then we have a heat map, so it's figured out based on the walls and the areas that this is where we should put our access points. In this case, it's selected 5 access points. And you can see we get a higher signal closer to the access point. The other thing we can look at is we can filter our survey results by channel. We can also filter our survey results by SSID. If we don't like what the software did, we can place access points by ourselves. And one of the things we can do that's really cool is that we can change the antenna parameters for a given access point. We can even include MAC address and IP address. But the antenna patterns, the software comes preloaded with hundreds of antenna patterns for many of the most common APs and AP manufacturers. So we can search for a pattern by vendor and then choose an access point. So you can see we have antennas that are dipole and Yagi, different kinds of antenna types. And if you don't find the antenna type you're looking for, you can draw your own antenna. So you can draw the antenna by pressing New and then moving the circles to the middle to make the shape that you want. Of course, you're not going to find an antenna with a pattern like this, and you can program the azimuth plane and the elevation plane. The other thing you can do is you can display heat maps just by signal strength, noise level, and SNR. There are many different parameters that the software collects. Noise level is important. Actually, what's most important is the signal strength and the signal to noise ratio, and but you can filter by a specific access point if you want as well. So this shows a signal strength of just one access point in the entire area versus signal strength of the entire facility. The phi data shows a predicted data transfer rate, which is important in some applications. And then so you can also filter heat maps by access points by using the bar on the left and selecting a given access point. The software in the passive survey automatically detects each access point and its channel. And then you can place access points on the map that are detected. So the software detected access points, but it doesn't necessarily detect their exact location. And then you can specify their exact locations, and that allows you to run a simulation. Now here I've put a push pin. I can put a push pin at any spot, and then it will give me more details about the measurement, including the access point, signal, and the SNR, and the data transfer rate. Now here I've installed a temporary access point to do an active survey, and I again get a heat map. In this case, I didn't necessarily walk around the entire facility. I only walked around a small area that I knew would have coverage, so we could predict the signal coverage. I will mention, when you perform an active survey, you should do you would go to survey and then select active with AP association, and then choose the access point that you're using for the survey, and make sure to do one survey at 2.4 and one at 5. It's not recommended to do them both at the same time. And then you want to walk around in your area just like in the passive survey, but this time you're connected to your access point and it's showing you a signal, noise, and SNR in real time. And while you're walking, you can monitor this to see how far you need to walk, because maybe you don't need to walk too far. Once your SNR is below 20 or your signal is below 70, then it becomes pointless, and you know that you need to install another access point further on. So again, we've run the active survey. We've put access points out in a couple of locations here, and this has generated a heat map of the facility. And in this case, we determined that we should place 2 access points in the warehouse, one on the left and one on the right. Here's another facility that didn't have a map, so we had to make one really quickly. In this case, the passive survey showed that we had a very high level of Wi-Fi coverage. Unfortunately, it's not our Wi-Fi coverage, so that represents a real challenge because the noise is very high. We can see we have some noise from these office jet printers, but on various unknown items. But this SMS-Nipon is the highest level of coverage here. It's actually a very good Wi-Fi signal, if I may say. It's almost like minus 67. But unfortunately, it's not our Wi-Fi, and we need to install our own Wi-Fi here. So again, we performed an active survey, walking around through the aisles, and the results show very good signal coverage again. Again, to keep the SNR at acceptable levels, we need to install at least 2 access points in this area. The software also comes with some sample projects, including for iPerf, which measures download rates and bandwidth in addition to the signal strength, but you do need a server to set this up. It's important in high density applications where you have many people connecting. And again, you can complete the active iPerf survey separately from the initial active survey. In this case, the active survey, it looks like they selected 3 or 4 locations for access points, or 3, looks like 3 locations. And we can see the signal strength from the first access point is pretty high throughout, in the passive, I should say. If you've completed several active surveys together, you can merge the data. And the iPerf shows a very high download rate on the left, closest to where the access point is. The download rate to the right is pretty poor. It's not terrible, but it's not great either. You can also filter data by packet retry rate and packet loss. Packet rate loss is usually going to be pretty close to 0, we hope. We can also look at the iPerf throughput, which I don't think was measured in this example, and the maximum transmit and receive rates and the MCS number for 802.11 AC. And we can also, this wasn't done either, but we can look at the overlap in different channels. Again, channel overlap should be as low as possible. Even in a high density application where you have AP cell overlap, you can set them to different channels automatically or manually to avoid that kind of issue. So again, we're looking at the signal strength of our access point here, the first one. And then the last thing you can do is a GPS survey. So rather than having to think about where you are on the map, especially for a larger area like an entire city block, instead of walking around and every time you take a few steps you click on the map, no, you use a GPS antenna, and a GPS antenna tells the AirMagnet exactly where you are on the map, and so it automatically records your location and the data at each location. So all you really have to do is walk around very slowly, and you can survey the entire city block. Make sure you have a laptop with a very good battery to do that, and preferably a tablet that's pretty light. Thank you.